Okay, let's dive into our first big skill, connecting your applications to data and storage services. Honestly, getting this right, doing it securely and efficiently, is table stakes for any cloud-native developer.
This is the classic cloud development challenge, right? The exam is definitely going to test you on this. They want to see that you understand the modern, secure patterns Google Cloud offers and that you're not still thinking about old, risky ways of doing things.
In this slide, it just shows that shift perfectly. We are getting away from the old days of manually managing SSL certificates, opening up public IPs to our databases, and hard coding passwords. The GCP way is all about using IAM for who can connect, a sidecar proxy for the how, and secret manager for the secrets. So the real hero here is this proxy. Just think of it like a little helper container that sits right next to your application. It does all the heavy lifting, all that complex encryption and authentication stuff, using the IAM roles you already know. The best part, your application has no idea it's even there. Now check this out. What's so cool about this connection string is that host parameter. Your app isn't connecting to some random IP address, it's connecting to a simple local path. The proxy just completely hides all the networking and security complexity. It makes your code cleaner and, way more secure. And this whole idea of a simple, secure connection isn't just for Cloud SQL. You can do similar things with other services. You can mount a cloud storage bucket so it looks just like a local folder using something called Fuse. You can connect to Firestore with its library. You can even use a nearly identical proxy for AlloDB. The principle is always the same. Keep it simple, keep it secure.
Okay, so our app is now securely connected to its data. What's next? Well, it needs to talk to the rest of the huge Google Cloud ecosystem, right? Whether it's sending messages with PubSub or grabbing secrets from Secret Manager, it's got to make API calls. So how does it prove who it is?
The magic behind all of this is a concept you have to know, Application Default Credentials, or ADC. It's basically a smart strategy that lets the official Google Cloud libraries automatically find the right permissions from whatever environment they're in. That means you don't have to hard-code a single key or credential file into your app. It's amazing. And it's not actually magic. There's a specific order it follows. First, the library looks for a special environment variable. If that's not there, it checks with the metadata server of the environment it's in, like Cloud Run or GKE. And if all else fails, for local development, it just uses the credentials from your gcloud command line tool. You really need to remember this search order for the exam. Now, not all API calls are created equal. The exam will expect you to know the difference between gRPC and REST. The simple takeaway is this. gRPC uses binary and HTTP too, so it's built for speed. Think high-performance, low-latency stuff. REST with JSON is your universal soldier. It works everywhere, especially with browsers. And please remember these best practices. Always use the official client libraries. They handle ADC and even automatic retries for you. Use field masks to tell an API, hey, only give me these specific fields, which makes things faster. And for goodness sake, always use pagination when you're dealing with big lists of results. All right, now for every developer's favorite part of the job, when things break. Because they will. When that happens, you have to know how to use Google Cloud's observability tools to find the problem and fix it fast, especially when it's live in production. The entire foundation of modern observability is structured logging. Instead of just printing out plain text, your app spits out logs as JSON objects. This one change is incredibly powerful because it turns your logs from a messy wall of text into a searchable, queryable database of exactly what happened. Just look at this example. We're not just getting database connection timeout. We get a nice JSON object with key value pairs. Now we can easily search for every log with a severity of error, or maybe trace one user's entire journey through the system using that request ID. And here's the payoff. In the Logs Explorer, you can run these super precise queries. You can instantly find all the error logs for a specific Cloud Run service, or pull every single log entry tied to one specific request. This is how you find the root cause of a bug in seconds, not hours. It's a lifesaver. Now for the why is this so slow problem, we've got Cloud Trace. It gives you this awesome waterfall view, breaking a single request down into all its different parts, which are called spans. You can literally see how long each little operation took, the API call, the database query, and immediately spot the bottleneck that's slowing the whole thing down. And for that 30,000-foot view of your app's health, you have error reporting. It's so smart. It automatically scans your logs for errors, groups all the identical ones together, and gives you a dashboard of your biggest bugs.
It tells you exactly which error is hitting the most users, so you know where to focus your attention.
Okay, wow, we have covered a ton of ground, from secure connections all the way to troubleshooting. So let's just boil this all down into the key patterns, the big takeaways you absolutely have to know for Section 4 of the exam. So if you only remember 3 things, make it these 3. For connections, hide the network details with a proxy. For authentication, let the environment handle it for you with ADC. And for diagnostics, make your data structured so you can query it. These aren't just tools. They are the modern way to build professional, secure cloud apps.
And that's our guide to crushing Section 4. Really, mastering these patterns, how you connect, authenticate, and observe your apps, isn't just about passing the exam. It's about how you become a developer who builds truly professional, robust, and maintainable applications on Google Cloud.